Welcome to question 7 on the graphic sample paper 2022. So shown below is a 3D model of an ice cream machine. Part A, in the space provided draw a well proportioned, so well proportioned is important here, freehand sketch of the elevation of the ice cream machine in the direction of arrow A. So A looking in this direction. So let's start off with the overall I suppose shape of our object. So we've got our base, and let's extend up the sides up there and there. I'll be happy with that. Our vertical line and our vertical line. So do it all lightly to begin with. In terms of proportion, so our width to our height is probably about just a little under twice the height, so or twice the width. So that distance, so once, twice. Yeah, I'm happy with there being my outline. Okay, then I'm going to step in a little bit for my tray. So step into there and there. I'm happy with those proportions, and just this little rectangular area for my tray, and approximately, I suppose, a little bit more than halfway up the machine. I've got this divide for a curve coming down, and I've got a rectangle mount for holding, I suppose, the lever. So that is about, I suppose, a third. So split this in three, approximately there. Okay, so that seems to be that little rectangle, and then I've got the lever. So it's a truncated cone, so we're going to be sloping out. Seems to be not far off the same height. So I'm just going to make that out. Just using it, my 3D sketching. I'd say that's kind of at the same height as my overall height. So about there and there. It's coming down, sloping down. Yeah, so something like that. Okay, and my little spout coming down just a small little distance, about the same height of that rectangle. Not really clear if that's still a cylinder or still a cone or a cylinder, but I've just drawn a cone. And it's the elevation, so you need to remember there's actually hidden detail for this tray. So coming in a little bit there and there, and then I'm going to have my tray coming down just a smidge, just about there. So hidden detail. Running along, and I'll go over my other edges now heavy. So vertical line down. Just finishing off all of those, making each of our heavy lines pop out off the page. And there's no mention of rendering, so I'm happy with that. I can leave that as is. Part B, the drawing below shows the incomplete perspective drawing of the ice cream machine body. The 3D graphic is also shown complete perspective. So I've got a vanishing point, and this 3D image to help us what we're aiming to, I suppose, target what we're aiming for. So we've got our vanishing line going back, so representing there. So actually, you can just do a little sketch of what we're drawing our VP, another VP. So a lot of these lines already vanishing, so we need to vanish back, back, and drop that vertical line. Okay, so I have this edge, I can drop vertically down. Now draw the base of that heavy. Now vanish this back. And this back. And this is a vertical member, same way as vertical there, so that will allow me to find this. Now what we need to find is the length here, so I could, there's a couple of ways that the easiest I find is I'm going to vanish that back and vanish this back, and where they intersect then that will give me the position of the line coming down. So vanish there, vanish there, and that's the position of that part coming down. I could also do the same with the base, vanish there, sorry, drop the vertical line down, vanish that back, and where they intersect, vanish it forward. But it's whatever way works for you in this particular question. Okay, and that is the completed perspective, and they're not asking for any shading there. On to part C. The logo of an ice cream machine is shown below. It is based on parabola AOB. AOB, there's a parabola with vertex O, so here's our vertex, a rectangle and triangles. So we've got a rectangle and triangles. There's triangles there for sure. We draw the logo and in the given rectangle A, B, C, D, A, B, C, D, A, B, C, D, and here's my axis. There's O. So let's divide up one side of our rectangle. So a line out here at any angle. I'm going to divide this up into 4 equal parts. So 1, 2, 3, 4. So number them off just to make sure we don't make any mistakes. 1, 2, 3, 4. Join 4 back to the end of my line, which is D. And 3, 2, and 1. So that's one side divided. I'm going to draw parallel to my axis from there. Okay, and this side I'll divide it up also. 4 equal parts, so a line at any angle here again. I'm going to draw through my, I suppose, preview it. So let's go 4 steps up again. 1, 2, 3, 4. And number them. 1, 2, 3, 4. Sliding set squares. join these now back to my vertex. So 1 and 1, 2, 2, 3, 3. So here's my curve for one half of the parabola. Okay, and to find it on the opposite side, I'm going to use axial symmetry. So here's my axis, stand true. All of those at 90 degrees. Compass, set it to that distance, swing through, set it to the same distance here again, and there to there. So let's look at it. Another 3 points and a freehand curve. Okay, so that is the parabola completed. Now I also have these internal shapes to draw, so let's look at some of the light lines they've given us. So I've got my D joining up and back to C, and I've got my diagonals joining to find points there. So let's start with those. D and C. And then I'm going to join the diagonals. Okay, I'm just trying to figure my various bits out. So for that, oh, and I need to join A to O and B to O. Okay, so I think that's all the light lines I need, and I should be able to construct a lot of this now. So where D joins up and crosses A, O, that will give me a point that I can join back. So that is from there, from there. So that's the pink triangle. I can then drop down, so actually finish and draw this in a triangular shape. So I've got the overall diamond, but now I need to break it down. So I've got this diamond, which we're following down and across, so down there and across to there, across there, so I can join those back to the center of my diamond. Okay, and that is everything I need. So lastly then, I need to color or shade the completed logo. So here is the completed shading or rendering. Okay, you can add whatever colors you want. I just went for something that is similar to what is given to us in the exam. Part D, a 3D model of the drip tray. So here's our drip tray. Removed from the machine is shown below. So here is that, a basic version of that drip tray. Also shown is the plan of the drip tray. So here it is. Draw a new drip tray similar to the given drip tray with length AB increased to AB1. So they want to extend that, I suppose, rectangular section out to its width. So what we're going to do is we're going to radiate out all our lines. So A is radiated out through B. We'll call this point C for my center, point D, and point E. So all of those points I'm going to radiate out. So radiate out A through C, D, radiate out, and E, let's radiate that out as well. So now B is located in this position, B1. C and B, their relationship is they're vertically aligned. So I'm going to get my set squares, and from B we go vertical, so from B here we're going to go vertically up, and that is going to find me point C1. Now D is also vertically aligned with that, so I'll actually extend that out, and that should find point D1. And then back here, parallel to that edge, I'll find point E. So here's the center of my new arc, my new semicircle. The radius is C1 to B1. That should line up there with, let's put that marked up. Okay, and go back here to D, from D to E, and down onto E. So that is our new drip tray increased in size. Next we're on to question 7E. The axonometric axis required for the isometric projection of the ice cream machine body are shown. So here are axonometric axes. The elevation and end view and 3D graphic of the ice cream machine or ice cream machine body are also shown. Complete the axonometric projections of the main body. So what I'm going to deal with first of all is this front face, say here. Actually, okay. So this front face is what I'm going to deal with first. Okay, but I'm going to leave out this curved area. Okay, it's like a quarter of a cylinder. Okay, so that shape there we're going to leave out. So let's project back my heights here in elevation to my view here, and I'll project the heights shown in, or the points shown in this view also. Okay, so they've given us the base, so we just need to extend that up onto the highest line. That's representing that edge. Projecting lines there without having my sheet taped down or lying flat. Okay, yeah, so that's creating a little confusion, so I project it back. Okay, and this one here. Okay, so that's a front part minus my curve. Okay, I'm now going to do the depth of it, so length there, forward, and I'll bring this forward here. Okay. So it's bottom edge. Okay, so now I have this curve that I want to find. Okay, here we have an elevation. So that's an elevation. And this is the end elevation. To draw an elevation, I need heights and I need length. To draw an end elevation, I need height also, but I also need the depth, or the width or the depth, whichever you want to call it, the depth of my object. What is common between the two of these is height. And that is what they're examining us on. Can we identify that there's common heights between these? So I am going to pick points along my freehand curve. So let's go here, say point 1 and point 2. Okay, and I'm going to find those heights now in my elevation. So I could actually measure them there. That might be the easiest thing, but I could also project them back onto this line. So it doesn't matter which way we do it, but I just want to establish these heights. Okay, so that's the height of 1 and the height of 2. So I'm going to get the height of 1. So here's the height of point 1 on both of those edges. And then I get the height of 2. Height of 2, height of 2. Okay, so I'm just going to label all these points now. I'll use colours just to help you identify between them. So I've got, that's 1, 1. I'm going to show a line between them. So this is essentially a generator between both of those points, and here is point 1. And the height. Call that H1. Okay, and just for the sake of it, you don't have to do this, I'm just showing you clearly. Here is H1. I also have H2, so here's H2, 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 that is point 2, point 2, and we will show the line that makes them up. Okay. So now I'm going to project those points and match them up in my view. So point 1, project it forward, point 1, project it forward. Let's project it back at 30 degrees. So point 1 and 1. So this is, I'll just highlight it again using my colours. That is that generator 1. So 1, 1. Now point 2, let's project that forward. Project it forward from my views. That's point 2. just highlight it again with my colour. 2, 2. So, there are my points on that curve. Draw freehand curve, joining them up down into my shape, joining them up, down. Okay, so that is the axonometric views of, or axonometric projection to create an isometric of that main body included. Okay, like I said, identifying heights between views, that is the important part. Okay, if you wanted to find any other point, if you even divided up 60, 30, maybe that's what you do in class, that's fine, but the key thing is establishing a height and finding the corresponding height over here to locate the points. So that's question 7 complete.